Okay. Now, free fall. What is free fall? Motion under gravity. No other force. Especially air resistance is negligible. If air resistance is negligible, it is known as free fall. Uh, Now, motion under gravity means that there is no other force but gravity acting on an object, and especially air resistance is either ignored or negligible. Or either we consider it as negligible or it is ignored. Now, what are the special things? Number one, only is force of gravity. In this case, it would be weight. Near surface of Earth weight and mass are related such that gravitational field strength is 9.81 newtons for each kg. 9.81 newtons per kg. Near surface of Earth, numerical value of gravitational acceleration is equal to gravitational field strength. What is gravitational acceleration? And what is gravitational field strength? So numeric value is same for gravitational acceleration and gravitational field strength. They both are 9.81 newtons for each kg. Now, if air resistance is ignored, acceleration of falling object remains constant. So all of motion are applicable. normal equation of motion for free fall and for object that has been dropped. Now, normal equation is V equals to U plus AT, but the same equation for free fall becomes V equals to U plus GT. And for a dropped object, V equals to GT. Because if an object is dropped, its initial velocity will be zero. And when initial velocity is zero, you can just simply ignore U. Now,
Can you
yes,
can you scroll a bit up? A student from our class needs to see some point.
mm, so could you please show the point about this again? Okay, I just saw the message. Okay, can we go on now? Okay, listen. If 2s equals to v square minus u square, how will this equation look like in case of free fall? 2, instead of a, we will write g. Instead of s, we will write h. Why? Because when an object is moving up and down, the distance traveled is actually change of height. V square minus u square. And if an object is being dropped, then it is 2gh equals to v square. Similarly, s equals to ut plus 1 over 2at square. And it will become h equals to ut plus 1 over 2 gt square. And if initial speed is 0, then h equals to half gt square, or g equals to 2h over t square. So this is how we can use the same formulas in free fall. Note, acceleration is a vector quantity. What is meant by vector quantity? What quantities are vector quantities? Quantities that need direction for the complete understanding. So acceleration is a vector quantity. Direction of acceleration is same as force causing it. So acceleration due to gravity is always downwards. And this is very important. Some students say that the acceleration due to gravity is positive or negative. It is neither positive nor negative. It is downwards. Now it depends. In some cases, we consider down as positive. Then acceleration due to gravity in that case will be positive. In some cases, we consider downward as negative. Then acceleration due to gravity will be negative. If downward is positive, acceleration due to gravity is positive. If downward is negative, acceleration due to gravity is negative. So there is no hard and fast rule that whether acceleration due to gravity is positive or negative. And most of the students struggle with this thing. One thing that you have to understand that acceleration due to gravity is neither positive nor negative. It is just downward. Now, in some cases, we consider downward as positive. In that case, acceleration will be positive. We will be making some graphs and this will make more sense then. Okay, let's see. Okay, we will be making so many graphs now. So stay with me. Now, okay, an object dropped from a building. No air resistance. So just for the simplicity, because we first understand something and we gradually introduce more and more variables. So for the beginning, we will be considering there is no air resistance over here. Now, if I drop something from a tall building, let's say here we have this building. On the top of a building, there is a person standing. So this person throws something downward. So as this object falls down, I'm capturing the position of this object at a regular interval. So let's say I'm making consecutive images at regular intervals of time. There is something that should tell you that the object is accelerating. How can you say this object is accelerating? All of the images are taken at regular interval, like at the interval of same time. How do you think these images suggest that the object is accelerating? Answer is because the distance between the consecutive image is increasing. If all images of falling object are taken at regular interval, the diagram shows the object is accelerating as it falls more distance every next interval. Just by looking at this diagram, I can see that the distance between the consecutive images is increasing. And if the distance between the consecutive images is increasing, it shows that object is accelerating. Now, I will be making graphs for this object because in this case, everything is downwards. Object is traveling distance downwards, object velocity is downwards. So we'll be considering downward as negative or positive, sorry. Okay. So this is the graph for distance fallen. This is the graph for speed or velocity. This is the graph for acceleration, the graph for kinetic energy. Now, first graph is distance fallen. Like there are different ways of thinking of different distance. Like somebody can be thinking of height of the object, like from the ground level. And I'm not thinking of height of an object. I'm thinking of distance that the object falls in like with respect to time. On x-axis, I have time in second. So what kind of graph I should be expecting? Now, it is a distance time graph, and I have to show increasing speed. If you remember, we have discussed that. How does increasing speed look like on a distance time graph? See, if you remember, increasing speed on a distance time graph. Look, the first car was traveling with increasing speed, and its distance time graph is like this. So it has to have an increasing gradient. So same case over here. The falling object is falling more distance in every next second. How can I show that on a distance time graph? So this is the kind of graph I should be expecting for distance and time. Now, what about velocity and time? And in this case, because the object is just moving in single direction, so velocity and speed will have same graph. And remember, because everything is going downwards, so we are considering downward as positive. So speed will be increasing. Acceleration and time and energy and time. Okay, acceleration and time. The graph has to be like this. Okay. Potential energy decreases like this. This is what is happening to the gravitational potential energy. And this is what is happening to kinetic energy. Okay. So this is gravitational potential energy, and this one is kinetic energy. And this is the point where kinetic energy is equal to gravitational potential energy. So this is the story for uh, an object that has been thrown. from a tall building. Now, what if and a person is throwing a stone upward and then catches it back at the same point? An object is thrown vertically upwards and caught at same point. So we throw an object vertically upward and then catch it back at the same point. So this is a person. So what he does is he throws an object upwards and then catches it back. So this person throws something upwards Can you hear me?
Yes.
Yes.
Okay. So so this person throws the object up and then catches it back again. So actually this object goes up and then comes back in the same line. But for the simplicity that we can understand what is going on, we are showing that we're showing the object in two different lines. So this is where the object is going up, and this is when the object is coming down. For this case, we consider upwards as positive. We are considering upward as positive. So downward will automatically becomes negative. Now, object goes up and falls back in same line. The resistance is ignored. Now, what will happen while object is going up? Because object is going up and gravitational force is down. So if a force is acting opposite to the direction of motion, What does that force do? How will that force affect the motion of that object? Answer is it will slow it down. Second question, what will happen when an object is coming down? In that case, force is acting along the direction of motion, so speed of an object should increase. So here we go. So we need these axes again. So and there will be a graph for distance traveled and one more thing. Distance traveled, then displacement, then speed, velocity, just one second. Okay. Now, first graph, distance traveled and time. How much distance this object travels? Now, pay attention. Okay, this is, uh, let's consider the 3 block time as object is going up, and then 3 block time, the object is coming down. So this is when the object is at the top, and this is when object is back. So object will be traveling distance with a decreasing speed while going up. So object will be traveling distance with decreasing speed while going up, and it will be traveling the distance with increasing speed while falling down. So there is a very simple difference between distance traveled and displacement. We are not drawing the graph of displacement. We are drawing the graph of distance traveled. So when an object goes up, it travels distance. When it is coming back down, it is traveling more distance. So this is how the graph of distance against time should look like. Now, what about displacement and time? This is the time for object to be at the top, and this is when the object is back. So object travels this distance, object goes there with a decreasing speed, and then comes back with an increasing speed. So this is how these two graphs should look like. Okay, graphs are very important. This is the kind of question you should be expecting to see in exam. So object goes up. So obviously, when object is going up, displacement, distance from the ground or distance from the point of flow is increasing. And when it goes to top and starts coming back down, the distance from the point of flow should start decreasing. So displacement increases and decreases, but distance travel only increases. Speed.
Can you explain that again?
Okay. Listen. What is the difference between distance and displacement? Distance means how much distance an object travels when it is moving. And displacement means distance of an object from a fixed point. Displacement means distance from point of throw. So when an object is going up, like look over here. This is the point of throw. I hope you can
Yes,
see the point of throw over there.
yes, yes,
And what is happening to the distance traveled as object moves up? Look, I hope you can see this.
yes, I can.
So, do you see the cursor moving on the screen? So,
Yes,
what is happening? What is happening to the distance of the cursor from the person who has thrown the object?
it's increasing,
And what is happening to the distance from the person now?
decreasing.
So, listen, this is very important for you to understand. I haven't seen examiner spelling out displacement in a paper. Examiner never says displacement. Examiner says distance from. If examiner says distance from, it means he's talking about displacement.
Okay, sir.
Okay, when he says distance from the person who is throwing the object, or this distance from the point of throw, so that distance will increase and decrease. So he's talking about displacement. And if he says how much distance is traveled by the object or the ball in this case, then it will be object travels distance while it is going away, and it travels more distance when it is coming back. So distance traveled and distance from are two different things.
Okay, sir. Understood.
Okay, now speed. When object is going up, the speed of the object is decreasing. And when it is coming down, the speed is increasing again. Okay. This is top, and this is back, and this is time in seconds. Now, what about velocity? Velocity is speed in a particular direction. So what happens to velocity? So while object is going up, velocity decreases, and when it is coming down, velocity increases in the opposite direction. So this is when object is at the top, and after the top position, when object starts coming down, its speed is increasing, but velocity, because velocity is a vector quantity, and when direction of a vector quantity reverses, you have to switch the sign. Before reaching top, object was moving up, and after top, it is moving down. So it means direction of velocity has changed. This is velocity, time in seconds, and this is where the object has come back. Now, how will acceleration look like? While going up or coming down, acceleration is always towards the center of Earth. Acceleration is always downward. So this is top, this is back, this is time in seconds, this is origin, this will be negative g or negative 9.81 meter per second square. So remember, for this kind of case, because we have considered upward as positive, and what did I tell you about acceleration due to gravity? Acceleration due to gravity is always downwards, always. Okay, so these are the graphs that you should know how to plot. Okay, tomorrow we will be introducing air resistance and drawing these graphs again, and then we will do projectile motion. And meanwhile, I'm not changing time for now. I need to change time because there's some classes that I have to change time for. So, but now it is 6:30 for tomorrow as well.
Yes, sir.
See you tomorrow.
Allah
Okay.
Hafiz.
Allah Hafiz.